Hi everyone, the next question we're gonna do is the one that involves the number of bacteria found in a sample of human tissues after infection occurred. So what we have here is this problem that has been modeled by this equation given here, n of t equal to 8 take away t, everything in the brackets, times e to the power of t take away 6, where t is in hours, so it does represent times, and nt is the number of bacteria in millions. We also have the graph of this function, so it's here. So on the x-axis we do have independent variable, which is in this case time, hours, and dependent one on y-axis is the number of bacteria, and again is in millions. So the first thing that we're gonna do is to find the time when all bacteria are dead. So just looking at this graph, when all bacteria are dead, so we can have like this graph goes up, 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 we reach maximum, and then the number of bacteria it's decreasing, 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 and it does look like at this point here it is equal to 0. So I would say the time is equal in 8 hours. But just to make sure, we're gonna solve this algebraically as well, because I'm not sure if my graph is precise. So let's do it algebraically. So for our function, in order to be equal to 0, means this y coordinate is equal to 0. So therefore, it means that n of t is equal to 0. So n of t is our function, 8 take away t times e to the power of t take away 6, and is equal to 0. So, and then, okay, when is this equal to 0? So we do know from before that e to the power of t take away 6 is always positive, so it's always bigger than 0. So therefore we are only left with this part here. So this equation is equal to 0 only when 8 take away t is equal to 0, and we can solve this for t is equal to 8. So the time is 8 hours. So when all bacteria are going to be dead. Okay, now the next thing that we would like back, maximum number, we do know, it does occur here, maximum. So this is the point here. So on the top of this graph, it's maximum. And how do we find the maximum? So we do know that slope here is equal to 0. So first here, looking at the graph, so to find the time in which the rate of increase of the bacteria is the maximum, it should be somewhere here approximately. So we do know that it's happening at the point of inflection, and point of inflection is the second derivative. So equation is equal to 0. Talk about is what is the maximum number of bacteria expected to be found in the sample. So maximum number of bacteria. So again, I'm just gonna go, it is equal to 0. So, and first derivative is, in this case, dn of dt is equal to 0. So that is when the maximum is going to occur. So algebraically, so you can use graphics calculators, or if you do have good graphs, sometimes you can read it off the graph, but we're going to do it algebraically. So I'm just going to copy this equation again, write it down. So it is n of t equal to 8 take away t times e to the power of t take away 6. So yep, that's the one. So to find the first derivative, so we can see that we do have like two functions here. So the first one is 8 take away t, and another one is e to the power of t take away 6. So I'm going to say that, okay, the first one, u, I'm going to call it u, is 8 take away t. Find the derivative of the first one. It's going to be -1. The second one is v equal to e to the power of t take away 6. And v, derivative of this function, is e to the power of t take away 6. And then times derivative of function in exponent. So derivative of this function would be only 1. So now we are using product rule here, product rule. So we're using product rule, which we already know how to do it. So product rule. So, and now we're gonna go back substitute into dn dt. So dn dt, using the product rule, we do know it's gonna be like n dash t equal to u dash v plus uv dash. So u dash is -1 times v e to the power of take away 6 plus u is 8 take away t, don't forget the brackets, and times v dash, which is e to the power of take 8 t take away 6. So now the next part here is to look, okay, so do we have anything in common? So yes, we do have common factors. In this case, it is e to the power of t take away 6. So what we left here is with -1. So we're going to take -1 plus, and this bit here, plus 8 take away t, close the brackets, equal to, let's simplify a little bit. So -1 plus 8 is 7, 7 take away t. Again, when is this derivative equal to 0? So dn dt is equal to 0 only when 7 take away t is equal to 0. As we do know, this part is always positive, it's always bigger than 0, so we don't have to worry about that. So therefore, the maximum will be achieved when t is equal to 7. So that is in 7 hours. You can use sign diagram as well to find this, but we're just gonna leave it here. So we do know it's gonna happen in 7 hours, but we still have to find the maximum number of bacteria expected. So number of bacteria, so which means we're gonna need this equation here, because this one is the number of bacteria. So therefore, okay, edit, cancel, or whatever. Okay, done. So therefore, when t is equal to 7, n of 7 is equal to 8 times 7 times e, 7 times 6, and is equal to e millions. Sounds good, doesn't it? E millions. So if you're curious, you can actually find out what e is equal to. Okay. So now that we have this, we're gonna go back to next part of the question. So we do want to find the time at which the rate of increase of the bacteria is a maximum. So page 4, and find the second derivative. So we can go d to n, dt to, and when this is going to be equal to 0. So first find the derivative. So so to find the second derivative, we do need the first derivative. So we're going to have here dn of dt is equal to, let me just remember, it's e to the power of t take away 6 times 7 take away t. Okay, beautiful. So this is the first derivative. So first derivative, and we're gonna use the first one to find the second one. Again, similar as before, we can see that we have two functions. The first one, second one, use product rule. So the first function is e to the power of t take away 6. Derivative of is exactly the same as the one above. V is equal 7 take away t, and v dash is equal, derivative of 7 is 0, derivative of negative t is negative 1. Substitute everything using the product rule, u dash v plus uv dash. So we're going to go back here, d2 and dt2 is equal to, substitute u dash, it's e to the power of t take away 6 u dash times 7 take away t, and then plus u is e to the power of t take away 6 and times v, which is negative 1. Don't forget the brackets because it's not take away 1, is times negative 1. Let's see if we can simplify this. Yep, so what we have here, this one, common factors, take it out in front of the brackets. What are we left here? 7 take away t, and then take away 1, equal to e to the power of take away 6. 7 take away 1 is 6, 6 take away t. So the same thing, when is second derivative equal to 0? It's only equal to 0 when this part of the equation is equal to 0. And again, we don't have to worry about this because why? Because it's always positive, bigger than 0. So therefore 6 take away t is equal to 0, and that's happening when t is equal to 0. So the maximum, the time at which the rate of increase of bacteria is at maximum is when t is equal to 6, in 6 hours. And I think that would be all for today. I'm just curious, what is E equal to? Can you find out? Thank you. Bye.